The Pythagorean theorem, also remembered as c squared equals a squared plus b squared, is a mathematical tool used in lots of courses, right from middle school through college, tech school, or even university. It's also commonly used by those in construction or landscaping or anywhere that you'd find workers dealing with squares, rectangles, vertical walls, etc. In other words, lots of places. It's a quick way to solve problems or to simply ensure that your corners are actually at 90 degrees or square. In this tutorial, we'll learn about how to apply the Pythagorean theorem to some problems, and we'll do so with two examples. Example 1. Determine the length of side x in this diagram. So first, we'll note that this is a right triangle. See the square here? That indicates that the angle is 90 degrees. And every right triangle will have a 90-degree angle in it. Now, checking that we have a right triangle is really important, in that the Pythagorean theorem only works with right triangles. So next, let's lay out our Pythagorean theorem as c squared equals a squared plus b squared. And we'll note that a, b, and c all represent the lengths of the triangle sides. So which is which? Well, we see that c must be the longest side. The others are added to it. And the longest side is here, across from the 90-degree angle. We have a fancy name for the longest side. We'll call it the hypotenuse. Now, a and b are the other sides. It doesn't matter which is which, so let's just mark them like this. Now let's plug all of these into our formula. We'll square a and b, so 3 squared is 9, and 4 squared is 16, and then we'll add them. So c squared is 9 plus 16, or 25. But we're not done. We want the side length c, not c squared. So we're going to have to square root both sides to get c by itself, and the square root of 25 is 5. So the length of our side x is 5, and we'll put the units as centimeters, the same units as the given sides. And we can confirm that c is the longest side at 5 centimeters, and that's what we'd expect for a hypotenuse, right? So we're done. Example 2. Determine the length of the unknown side in this diagram. So first, we'll confirm that it is a right triangle. This angle is 90 degrees, so perfect. Next, let's lay out our Pythagorean theorem. C squared equals a squared plus b squared. So which side is the hypotenuse c? Well, we remember that the hypotenuse is always the longest side, and it's always across from the 90-degree angle. So this must be c here. And so a and b can be the other sides. Again, it doesn't matter which is a and which is b, so we'll just mark them like this. Now, we stop and realize that we're not solving for c in this case. The unknown, well, we'll call that a. So we adjust our Pythagorean theorem formula to have the a on the left, and we do that by subtracting b squared from both sides. And we can just remember that c is always the biggest side, the hypotenuse. So it'll be the first one here, and we subtract the leftover side, b in this case. Now let's plug all the numbers into our formula. We can square c and b, so 10 squared is 100, and 8 squared is 64, and then we'll subtract them. So a squared is 100 minus 64, and you may pull out a calculator or not, just do it in your head if you want to try that, but we get 36. And we're not done. We want the side length a, not a squared. So we'll have to square root both sides, and so we get a, the square root of 36 is 6. So the length of our missing side is 6 meters. Again, we'll use the same units as our given sides. And we're done.